Hey Year 11s, welcome to our Lesson 3 on our flipped classroom lessons. The focus for this lesson is the biomechanical principle of balance and stability. When thinking about balance and stability, it is important to understand that every person or athlete must be able to maintain balance and stability. An athlete's loss of stability can have a negative effect on their ability to perform a skill of their particular sport with control. And if you've had loss of control, that can affect factors such as force production, thinking back to force summation that we've learnt in our previous lesson, and accuracy. If an athlete has stability, this can have a positive effect on their ability to perform the skills of the sport with control. And having control, that athlete can use the principle of force summation to produce maximum force, resulting in a better performance. So thinking about balance and stability, there are three key points to understand and remember. The first one is base of support, which can be referred to as BOS for short. Secondly is the line of gravity, which is also known as LOG. And thirdly, the centre of mass, commonly referred to as centre of gravity, but for this, today, and for all the other lessons, we're going to refer it as centre of mass. So let's have a look at these three key words a little bit closer to grasp a better understanding of these key words. Alright, so the first one we're going to look at is base of support. Alright, and this is basically simple, alright, and it's basically the area in contact with the ground and the distance between those particular points. Okay. Now if we were to look down here and look at the handstand one to start off with, the area that is in contact with the ground is her hands. Okay, so that is the area that is in contact with the ground. And if we're looking at the distance between those particular points, that is here from the hand all the way to the other side. And that is known as our base of support. Alright, if we were to move on to the next picture, with the lady that is just on 1 foot, we look that her base of support has only got 1 foot on the ground. So the area that's in contact with the ground is the foot, which is here, and the base of support is from those between those 2 points. So that is her base of support there. Alright, and if we were looking at the person on the far right, okay, you can see both feet are in contact with the ground. So feet, both in contact with the ground. And then we're looking at the distance between those 2 points. So from here, sorry about my straight line, all the way to there, that is our base of support. Alright. So basically, you could look at it as in terms of 2 feet, and the person on the right, 2 hands, or 1 foot. So any area that is in contact with the ground, okay, and the distance between those points is our base of support. Alrighty, let's move on. Alright, and just to give you a clearer understanding also, alright, so looking at the weightlifter on our left, you can see that this particular person here has got a wide base of support. Alright, so if we're to look over here, right, wide base of support, we've got the contact with the ground is his feet. Contact with the ground is feet, and the distance between those is all the way there. Okay, so to understand this is if you've got a larger base of support, then you basically mean you are more stable or your stability increases. Alright, and if we look at the lady on the far right here, alright, The feet, once again, are in contact with the ground, and her base of support is this distance here. Alright, so as you can see, her base of support is quite narrow, which means she's less stable than the person on the far left. Alright, so the upright body is less stable when the feet are parallel and close together because the base of support is narrow. Alright, if you're to widen your base of support, you're seen as more stable or your stability increases. Alrighty, let's move on. Alright, just to give you an example, you could try this at home or if you've got a brother and sister. So if you were to stand with your feet together and have someone push you from the sides, alright, and then have another attempt where you spread your legs about 3 feet apart and be pushed again. Which one would be more stable and why? Alright, our next one, centre of mass. Okay, and this basically means the point at which the mass of the body or object is equally balanced. Alright, and we're going to look at, we'll get a different colour here. Basically, you need to understand, how do we find our centre of mass? Alright, and it's basically a very simple method for determining this. Alright, so if you have a picture, so I've got several pictures in front of me, and I want to find the centre of mass, the part where each part is equally balanced. So what I need to do is I need to draw a box around the outside of the entire person. Okay, so I'll give you a demonstration, and I apologize for my lines. Okay, so a box. Okay, we come all the way down here, all the way here, and then up. Whoops-a-daisy. Okay, so I've drawn a box. And then I need to draw diagonal lines across the box. Alright, so here, I draw a line all the way across here to meet to the other side, and then I'm going to draw a line here where I meet to the other side. Okay, and basically where those two lines intersect is known as our centre of mass. Okay, so for example, roughly, because my lines aren't very perfect here, this guy's discus thrower here, his centre of mass is roughly about here. So wherever those lines intersect, that is known as our centre of mass. Alright, and if I was, just moving on to my next example here, if I was just standing upright, alright, my centre of mass is pretty much close to where my belly button is or my navel area. Right? If I was to raise my arms up, my centre of mass would move slightly higher up my body. Okay, so for example, in this child here, her centre of mass is gone slightly higher. Okay, so your centre of mass, if you raise things up above you, your centre of mass will rise. And also, you can get your centre of mass found outside your body. Okay, for this example here, where this guy's doing a bridge, you can see that his centre of mass is outside his body. Alrighty. Okay, moving on. Alright, we also need to know that centre of mass changes depending upon the body position. So for example, you can see Beatrice here in the discus picture. Her centre of mass is lower because she is bending her knees. Alright, so her centre of mass is lower. And then if the lady on the right, if you were to raise your hands up above you, right, her centre of mass has risen. Okay, so once again, bending your knees, your centre of mass lowers to the ground. If you raise your hands up, then your centre of mass rises. Okay. Alright, next one. Okay, is our lucky last one, is called line of gravity. So this means the vertical line which passes through the centre of mass to the ground. Alright, so let's get this back up again. Alrighty. Okay, so we know in this picture here that this lady's centre of mass is pretty much roughly about here. Okay, and we know in this picture this lady's centre of mass is about here. So basically, vertical line which passes through the centre of mass. So this vertical line needs to pass through the centre of mass of this lady doing a handstand. So it's going to pass through. Okay, and that is known as your line of gravity. Alright, and as you can see here, it's passing through and it's in the middle of its base of support. Okay, so remember the base of support was where the hands were and the distance between them. Okay, is my base of support. Sorry about my line there. Okay, so that line of gravity will fall straight down the middle to the ground, and it's in the middle of our base of support as well. Alright, moving on to the lady in the middle here. Alright, once again, our line comes through our centre of mass, okay, to the ground. Okay, and once again, it's in the middle of its base of support, because once again, our base of support is what is in contact with the ground and the distance between them. Okay, so line of gravity is basically a line that goes through the centre of mass. Right, and as you can see on the far right here, got a cheerleader. Basically, her line of gravity falls outside her base of support. So as you can see down here in the yellow, that's her base of support. Alright, and her line of gravity falls outside her base of support. So this lady here is seen as less stable than the other two pictures. Okay, because she's only got one thing on the ground, which is her foot. Alright, so those are the three main important things to remember: base of support, line of gravity, and centre of mass. Alright. Alright, just a few other things to understand. Alright, if the line of gravity falls outside the base of support, you are relatively unstable. As you can see here, if I was to push that particular girl over, she would fall over straight away. Right, and as you can see, the lady on the far right, if the line of gravity falls within the object's base of support, okay, and as you can see here, okay, her base of support is here, okay, and her centre of mass is about here, so the line of gravity falls within the centre of mass, falls within the base of support, sorry. Okay, so that equals more stability, or increases the stability of that particular person. Alrighty. Okay, let's look at increasing stability. So basically, the wider the base of support, which we looked at early on, equals more stability. Okay, so the more further you move your feet apart, the more stability increases. Alright, if I lower my centre of mass, so for example, if I bend my knees and get closer to the ground, I'm seen as more stable. Okay, my stability increases. Alright, and if the line of gravity is within the base of support, okay, then I'm also seen as more stable, and basically means it has a longer time before it gets out of my base of support. Alright, let's just have a look at some examples here of the three key words that we looked at earlier on. Alright, Alright, so we're going to start off with our sumo wrestler first. So once again, to find your center of mass, you actually have to draw a box around the outside of that particular person. Okay, sorry about my drawing of the lines. I apologize once again. Okay, so as I've drawn a box around the outside of my particular sumo wrestler, I have to draw diagonal lines all the way to the other side. Okay, and then to the other side. And where those two lines intersect, that is known as my center of mass. So for this sumo wrestler here, his center of mass is pretty much close to his belly button there. Alright, then we're going to go and look at our base of support. Alright, what areas are in contact with the ground? Well, as you can see here, he's got his feet on the ground, and the distance between those is our base of support. Right, so that's known as our base of support. We've got center of mass, and once again, our line of gravity goes through our center of mass. Right, so if I draw a line down here, that is my line of gravity. Alright, and as you can see, it is in the middle of my base of support, and my center of mass is lower. So for this sumo wrestler, I'm seen as more stable. Alright, if we were to move on and look at the gymnast balancing on one foot, let's get a different color, guys. Okay, so once again, we need to find the center of mass. So we need to draw a line. Sorry. Alright, and then we need to draw a diagonal of where it intersects. Okay, and her center of mass is about here. So my lines up very straight once again. Alright, so this is our center of mass. Our base of support, as you can see, is the area that's only touching the ground is her foot. Alright, and that is our base of support there. Alright, and then the line of gravity is what comes through our center, what goes through our center of mass. Okay, so that is our line of gravity. Right, as you can see here, this particular female that's balancing on one leg is less stable, so will lose stability quite quickly because it's on one foot, and her line of gravity falls out of her base of support compared to the sumo wrestler. Alright, what I'd like you to do is try and attempt to label the center of mass, base of support, and line of gravity for my weightlifter below. Give that a go. If you have any questions or any concerns, just ask me in class. Thank you, Year 11s.